Hello. I was like, I wonder what that is. It's because I set my camera down because I moved my laptop. That's what that was. All right. All right. So, how many people we got? Pretty good badge. You got on it today. I like it. I like it. All right. Cool. So, I thought Donna was going to talk during our normal lecture time, but she'll be talking at 2 p.m. I put the Zoom link in Slack for you guys. So I'm going to end the lecture. Excellent. I'm going to end lecture at like 11, so you guys still have that hour of lab time. So that way you guys don't lose any time for your group project. So hopefully that helps alleviate any stress. So that's my plan for that. Yeah, so Donna will be doing a career services Zoom meeting at 2. You guys are like required to attend. It's just like if you were doing any other kind of thing during lab time. She's a really great resource. You guys are all Augusta Tech students. You guys get full access to all of their career services. Donna's really nice. She's really good at what she does. So highly recommend using her as a resource. I'm sure they do it too, but like when I went to college, like my career services person, like I just literally needed someone to like sit and listen to me talk while I tried to figure out what I wanted to do with my life. So they can also be that person for you too. So that's what's up. We're gonna end lecture a little bit early so you guys get your full lab time. So that way there's no stress going on. Today we're gonna be talking about I'm trying to open everything up too. We'll be spending some time with some more advanced algorithm concept and data structure concepts. Some of these are a little bit weird in JavaScript to talk about because JavaScript doesn't really care how you handle things, but we'll spend some time talking about it. I also, before we get started, want to find some videos I want to put in. I'll put them in Slack and then I'll put them in the syllabus later so you guys have them. I'll just put his whole YouTube channel in here and then you guys can find whichever ones you think will be the most helpful. So there's that, so you guys have that. All right. Cool. It's Friday, guys. We only got one more week till spring break. It's exciting. All right. Cool. I'm gonna go ahead and share my screen and do all of my moving everything around so I can actually see what is up and get started. Alrighty. So before we start looking at new content, do we have any questions about yesterday's content, Big O, recursion, or like practicing writing out code by hand? Like, I guess I have a question for you guys. Like, besides it's something you have to do for interviews, so you should be good at it, why do we think we care about like handwriting code and doing pseudocode? Why do we care? Besides, like, we have to do it for interviews. right, so Sarah says problem solving. Chuck and Lexi both say thinking it through. Tyler says because VS Code does half of the formatting for you. This is true. I can type HTML5 and it does all the things for me. I would have to genuinely think really hard about what everything's supposed to be for the HTML head because I don't write it a lot. I just either use a template like Pug or I do HTML5 and just let it fill it in for me. So, and then Diane agrees with Tyler. Yeah, like I'll tell you what, like I would have to turn in coding tests handwritten and he would grade it like a compiler. So if you forgot like a bracket or a comma or you misspelled something, your program doesn't compile. That sucks. You fail. So I'm definitely not going to be that mean with you guys, and most interviewers aren't going to be that mean, but it's a really good skill to practice. Yeah, and Jimmy says because it gives us a better understanding of what we're doing. Yeah, I think handwriting it, I know for a fact that handwriting things versus typing uses a different part of your brain too. So you're strengthening your overall brain's ability to comprehend code. So like it gives you a different understanding and a better understanding of what you're doing. All right. So yeah, that's the big thing. I genuinely really want you guys to practice handwriting out code. Yeah, and that's actually like, I remember I had a teacher, some of you guys might have met him, Harley Eads. He did that talk about the math thing. So I think a couple of you guys did it. And like, we weren't allowed to have computers in his classroom because you have to handwrite everything because it's the same reason I don't use PowerPoints with you guys. Like, it's been proven to be really ineffectual at like long-term retention. So we don't use PowerPoints and I want you guys to handwrite stuff out. That's why I gave you guys whiteboards too, to hopefully let you guys, I also think sometimes it's very satisfying to just like be like, to take like, you spent time with some code and you're like, never mind, this is stupid, and crumple the paper up and throw it away. I think that's much more satisfying than just backspacing it all on the VS Code or whatever you're using. All right. So that being said, these are some things that might be really good to practice doing by hand. So far in JavaScript, the only way that we've organized data has been in arrays or objects. Technically, in JavaScript, all of these things that we're going to talk about today at like their fundamental level will still be either an array or an object. But other object-oriented languages have much more strict standards about what the actual data structure should look like. So we're going to talk about all of those so we can have a better understanding of how other languages work, plus get a better understanding of how like we'll organize data in general. Because sometimes these data structures give our code more structure, so it's easier to work with different kinds of data. I'm also probably going to try to figure out how to draw for you guys again, because I do a lot of drawing for this section. Yeah, yep. I might just get my other computer set up, and that might take a minute or two, but I might do that. Yeah, when we get to the drawing point, I'll just set up my other computer and do a digital whiteboard. Or eventually I'll stop being cheap and just go buy another drawing tablet. Let me actually enjoy this empty terminal for a second while I asked for people to buy me things. Okay. Excellent. Let's see if we can get somebody to spoil us and give us that so you guys don't have to suffer with me trying to write upside down for you guys. All right. So our first structure is a linked list. So just kind of like thinking about it, what do we think that means? Lists that are related. That's a really good way of putting it. Yeah. So we know that when we make an array, that none of the things inside of the array inherently have a relationship between them. So when you make lists, lists are composed of your data and a node. I already want to draw. All right. Give me like 30 seconds to set up a whiteboard thing. The drawing tablet I have is too old, so I have to set up my old, like, busty laptop to use my old busty drawing tablet. So I don't know, everybody, like, give me a movie recommendation while I take some setup time. What's like your favorite movie ever of all time? The Hedgehog? Like Sonic? Or like, is this a different movie? Pulp Fiction, yep. You know, it's a sad French movie. Oh yeah, I remember you talking about it when we talked about foreign movies. I remember now. Pulp Fiction, the classic. One of my friends was talking and like he makes that joke all the time, and then he would like looked at me and he was like, I don't think I've ever seen Pulp Fiction. I'm like, what? Tyler says pay it forward. Chuck says the Green Mile. I did this internship and I was in the dorms all the time during this internship, and there was like this shared dorm rooms, you know, and there was this. I don't like this. Sorry. They would always have like TVs on in like the common rooms, you know, which is cool. That's fine. But the entire summer, alls I watched was The Green Mile and Thunderdome. That was the only two movies that were ever on that TV. Got more Armageddon, Rush Hour. I enjoy Rush Hour a lot. I think it's really funny. Finding Nemo makes me feel better when I'm sick. Mine is Studio Ghibli. Like that's like what I like if I'm sad or I'm sick, like that's my like go-to is like I watch like Spirited Away for like the 10,000th time. All right. I don't have a movie in mind. But I would like to share some news that the cyber headquarters delayed the move to Fort Gordon that was supposed to happen in June. It's a huge, nice-looking building. There was an overhead shot in the Chronicle this morning. Interest. So then I should be able to do this office space. So this is the same digital whiteboard that I used before. I put the link in Slack so you guys have it, so that way you guys can see me draw, and hopefully it's not as awful as like me trying to write upside down or use my mouse. It's not going to be great, but you know, it's me. So. Cool. All right. So that should be at least easier to see and at least easier to understand what I'm doing, I hope. Yeah. Interesting. Cool. I'm going to give everybody a second to get all their screens situated so you guys can see that. Because I know that like it's hard to have, like I literally have 4 screens now. It's too much. I just want to be able to just sit on my couch with just my laptop. That's what I want. Cool. Okay. All right. So just to come back to where we were before, I didn't think I was going to want to draw that quickly, so that's why I didn't set anything up. When we use arrays in JavaScript, there's not any relationship between any of them. Like, it's just kind of like a junk drawer almost. You can put whatever you want in there, and like things are touching each other, but they don't really have any relationship between each other. When we talk about linked lists, they're made up of 2 pieces. So this is traditionally, woo, ugly. Here, hang on. Erase, let me erase, no. It even has a grid and I still can't draw a straight line. It's very sad. There we go. And it's made up of 2 parts. This is a very short linked list. So the first part, switch colors. Right here, this is our actual data. And this value can be like null or anything that you want. And then this other part, this blue part, is our pointer. You can't see. There's a link in Slack to get onto the whiteboard. Because I'm on another computer, so I can't screen share it. Yes. So the link for the whiteboard is on Slack. Because I literally have to get another computer to get my tablet to work. It's very sad. But that's why I don't ever throw anything away. So I'll give you guys a second to join us. Is no worries. Cool. Hello. Okay, so I see people writing, so I'm assuming you guys are G2G. All right. So this node part right here, I'm sorry, this pointer right here is this blue part is our pointer. So our blue part is the pointer. And then our red part is our data. Oops. All right. So what this means is that everything has a direct relationship to each other. I will take a screenshot of this. I will take a screenshot of this and post it, possibly, somehow. Can someone take a screenshot of it and post it, because I don't have a mouse connected to this computer, because this is the computer that I killed by filling a mirror on it. So the keyboard and mouse don't work. So I will, at the very end, if someone else doesn't post a screenshot, I will post a screenshot of it. Just be patient, because I'm using a computer that doesn't really work. Does that work for people who are watching on their phone if I post screenshots of the whiteboard later? Sarah, scroll up a little bit, Sarah. I think you might be all the way at the bottom. All right, so Tyler, let me read your thing and then I will answer you. So Tyler asked for relational versus unrelational. Is the relation between items themselves or something we could relate them together? So types of dogs being all dogs. But like, I like think they're all different, so would they be considered related because of me? So what I mean by relationship is not necessarily logic relationship, but connectedness relationship. So in an array, if you change or delete items from the array, it doesn't necessarily affect the other pieces in the array. In a linked list, as we'll see in just a bit, if you change or delete stuff, it will affect the rest of the list. So that's what we mean by relational. Let me see. Sarah, what is your Zoom at? Is it at 100%? Ooh. Someone just drew a huge black line. I zoomed all the way out. All I can see is scribbles. All right. So then I'm zoomed in at about 100%, and I would just zoom into the little few scribbles because that's all it is right now. There's just a couple few scribbles. Woo! Look at that. Chuck coming through with screenshots. Yeah. Thank you. I appreciate it. I am kind of seriously considering stealing one of those really big whiteboards and putting it behind me. I'm sure nobody would care, right? And I think it'd be easier, especially for this data science section. So we got some good questions. We got a little bit of technical difficulties. Are we good now? As I can see, our few scribbles lost in space. Yeah, I think this is one of those things like Photoshop that you can just zoom out for forever. Cool. Yeah, maybe I'll steal that big whiteboard because that might be easier. Except everything would be backwards, right? Like if I held the board up here, it would be backwards. No? Okay. We'll do some testing. Maybe I'll steal one. I'll have to probably, I could probably just take it and no one would notice. I'll probably ask though. That's probably the better thing to do. Yeah, I have a mom car, so I'm not too worried about transporting it. I'm more worried about getting yelled at for stealing stuff. So it'll be all right. We'll figure it out. We'll do this for today and then I'll figure out a better solution for next week because I'll probably do a lot of drawing. So we can get everybody on the whiteboard thing. That'll make it easier. If this totally sucks and you guys hate it, then I will figure out a better way. I'll either figure out how to get the webcam to be a better doc cam, or I will steal a bigger whiteboard, one of the two. I'll figure it out. So let me know if you guys absolutely hate this like digital whiteboard or whatever. So let me know how you guys feel about all that and what you guys would want me to do. What sounds preferable? All right. So let's go ahead and, Hatred, much stresso. Mucho stress. Yes. Yes. Yeah, we will definitely post screenshots of those so that way you guys are at least with me. So far, I haven't drawn anything else. So we'll suffer for today and then we will figure out a better solution for Monday. So linked lists have this one-way relationship between nodes, and this whole box is a node. And that just means it's a thing that has a pointer and data in it. What we mean by pointer is it tells you where to go next to find the next piece of data. This is really important in languages like Java and C# because you will do things like by reference and by name. And so understanding that sometimes you don't access stuff by their position, but by their relationship to other pieces of data will really set you up to really understand what these pieces are doing. And we'll look at code too, so you guys will have some code examples too, but I think the pictures are a good place to start. So we have our node that contains pointers and data. Pointers are just basically like, hey, the next piece of data is over here. And this goes all the way back to like when we start thinking about physical memory allocation, which is why in JavaScript, we don't super use this, but we need to understand how this works for interview questions, for other programming languages, and understanding that sometimes using other data structures is really important. So our data is our actual value, our string, our number, whatever we're saving, and our pointer is a reference to a memory location for the next piece of data. And you know, again, in JavaScript, we don't super care about memory management, but it still tells us, hey, the next piece of data is over here. When we get to this part right here, let me change colors again. To pink. Notice that this last piece right here, this X, that doesn't point to anything else. So this is sometimes called a null pointer. It's the end of our list, and that's how we check to see if there's anything else in our list or not, is we use this null pointer. Chuck did put a screenshot of most of this picture in Slack if you want to see most of it. The only thing that's different is I've underlined one of them and said it's a null pointer for the X. And we'll post screenshots and I will get ooh, yeah. Lexi just posted a better screenshot too. It's just a little bit more zoomed in and updated. Hey, okay. It's a updated one. It's not better. Both of your screenshot skills are invaluable. And it makes my life a lot easier because I literally don't have a way to take a screenshot on this without unplugging everything. So I appreciate both of you. Both of you get gold stars. Cool. Yeah, and we'll just, you know, keep doing screenshots and all that. And Monday I will have a better solution. So I'm sorry that this isn't perfect. And so Monday we'll have a better solution. All right. So that's the basic structure of this. And so when we use our linked list like this, we are establishing a relationship in one direction is the other thing I really want you guys to understand about a linked list. It's really hard to go backwards. We don't necessarily get to go the other way with just a singularly linked list. We don't get to see that way. We can only go forward. So times that linked lists are really useful are when you want things to be in order related to each other and break if you're missing something. off the top of my head, stuff like, you know, an alphabetized list. A lot of like alphabetized stuff is really like all that's coming to my brain. Things that have some kind of order to them tend to be stored in linked lists because we care about containing that order. Okay, there we go. I'm gonna drag this over. This is come on, go over there so you guys can see this. A list of IDs, yeah. You know, stuff that's like has an order to them that we care about preserving the order and that we care about preserving the relationship. So like this is previous and next in the web browser. I wouldn't super think about linked lists like this because we'll talk about doubly linked lists in just a bit, and that will be much better for that kind of structure. But yeah, and then also notice that they have this in the screen share part that they have their null hanging out at the end over here. I don't typically see that kind of notation. Typically people just be like, this is the end, and the pointer doesn't point to anything. But that's probably a little bit more accurate representation of what it's actually doing. So the very last node in a linked list is pointing to null. And so it's an invalid memory location. And that's how we know that the list is empty. Cool. And so it's like maintaining a directory of names. This one right here, number 5, performing arithmetic operations on long integers, seems really weird, but why do we think we would use a data structure to do math? Why wouldn't we just do the math? Why do we think we would need a data structure to hold math? Because we need to remember previous values, and then sometimes data isn't numbers. So yeah, maybe we want to save stuff and move on to it. Yeah. Another thing in other languages is memory management. So sometimes if you're doing a lot of math, your numbers might get too big to store in one single number. And so you'll have a linked list to store really big numbers. And then we really care about the order because, like, you know, 10,050 is a much different number than 50,010. I don't super care about that representing sparse matrices. So yeah. So let's look at some code about what a linked list looks like. All of this stuff that I'm going to do is move this so you guys can see it. All of this stuff is in that probable happiness array repo. So I have just JavaScript ones. I do also have one in C# if you guys want to see what it looks like in other languages. You don't have to. It's not vital. I just want you guys to have exposure to other languages too, so you guys can be like, oh, I like that structure better. But yeah, so this is the inside the data structures folder inside of the probable happiness repo. So you guys can see this. So this first little piece right here is just our class constructor, so that way we can make more than one list if we want to make more than one, specifically our nodes. And nodes, again, are that box that have data and a pointer. So the first thing that we do is This is some ugly notation, right? Like that head.next.next, that's weird. What do we think that's doing? What do we think like lines 9 through like 15 are doing? 'Cause that's weird. What do we think that's doing? Right, so Tyler says adding the next linked node, moving through nodes, yeah, and telling it where to start, making lists. Yeah. So our very first one, we create a head. And so typically these linked lists are called heads, and then tails are your very last one. So we create a head that's our very first node, and we give it the value of 12. And we know that it's the data that's being handed in for position, I'm sorry. We know that the value 12 is being passed into the data part for this node because the constructor is asking for data. And then look here, our default value for our pointer is null. So what does that tell us? It'll end. Yeah. So when we create a node, it automatically says that that node is the last node, which is really nice. So that way we don't have any weird like exceptions happen because it's trying to point to something that doesn't exist. So we make a node with the value we hand in, and then we say that's it, that's the last one. No more. So, all right. So with that being said, when we just add that dot next, that's how we change it. So that way we're not just having a bunch of individual little nodes that don't have any relationship to each other. So we say, okay, so head.next is this value of 99. And then we can add a third node and, you know, okay, that's kind of annoying. But that is how one way to do it in JavaScript is with a class and constructor. And this is also why we care about that class constructor thing, is if we need a data structure to behave, I'll just go with just behave. We just want it to behave. You can use a class to give your data a lot more structure, which can be really nice if you need things to have a structure. I think my shirt just ripped. That's funny. All right. How many necks can it have? Nick asked, how many necks can it have? Theoretically, however much memory you have on whatever you're running it in. So, a lot. And then this right here just prints out the list. That sounds messy. Yes, so this isn't typically what we do. This is just a pretty like, we're adding things and we're adding the relationship. So this is not typically how we do it. This is just how we can see what little nodes are. So any questions about this little tiny example? Here, I'm gonna uncomment this. And comment out the bigger one. Yes. Yes, that's fine. Maybe it's not fine. It's unhappy with me. Why is it unhappy? I don't know why it's unhappy with me, but it is. What? Oh, it's unhappy because I didn't actually close the comment. That's fine. Okay. So then we just run whoa. Oh, I didn't save it. Yay! Okay. So that's all it did is we added stuff to it using this kind of ugly notation. And then we just printed it. We used a while loop to go through. So notice that what we do, this is a neat little loop. So does it have to be named linked list? So Sarah asked, does it have to be named linked list node? No, it is called that because that is the class we created up here. But if you called the class like Fluffy Bunny, all of these would just be new Fluffy Bunnies. So as long as the class name and this match, you can name it whatever you want. Naming it this is probably the most appropriate thing to name it, unless you know what kind of things you're storing in there. But again, like a class is kind of just like our blank template for everything else. So you'd probably just be like, this is what a list looks like. And then you would name your implementation of the list, you know, like student names, Fluffy Bunny names, whatever. So Sarah asked, can you have more than one at a time display in Node? Like, can you put more than one piece of data in a node or something different? Can you have more than one list? Okay, I just don't know what you're asking. Can you have more than one at a time display in Node? Can you have more than one list at a time? Is that what you're asking? Yeah, and so that, so you have color and number list show node when you call linked list. If I had named them different things, yes. The reason that I commented them out is because they override each other with current, I think is what they override each other with. I didn't do a good job of separating my variables. Head, I think head is the reason that it's angry with me. I don't have them scoped properly. If you scoped things properly, you could just reuse them all and have multiple lists, and you probably would. But I use the same variable in the same scope, and so mine are very angry at each other, and I can't run both of them. If I went through and, you know, called like one of these start or something else, they would behave. But I have two variables that are scoped to the same scope, and they're very angry with each other. But yes, you could have as many implementations of that class as you want. You would just have to use some kind of scoping to keep them separate or name them different things, and they would work. All right. So that's a short little one that shows you guys like the basic structure. No. Here. Oh, yeah. One of these days, they're going to medicate me for ADHD and I'm going to be unstoppable. I had to be nerfed. I'm too powerful. Okay. All right. Let's look at this loop. So this loop I think is really neat because I think it's really succinct in how it goes through this linked list. So we look to see if current is empty, it's pointing to null, and then we just console.log the current.data. And current gets set to our head, which is pretty cool. So it gets set to that very first linked node. And then each time we go through the loop, we assign it to the next piece. until we hit null. I think it's a really nice little succinct way of looping through a linked list. And that's also sometimes why we use different kinds of data structure, is because traversing them can be very impacted by what data structure we pick. And so yesterday we talked about like complexity and that kind of stuff. If we're using different data structures, we can reduce our complexity and make our code run faster. So if we know that the only time we're really going to use our data is if we are like going in order, using a linked list might make sense because it might be a lot faster to do it that way than if we were to use like an array or a different data structure. Cool. So any questions about this part? This is about like, if you understood this part, you are exactly where I want you to be. Okay, so I got a yes. And we're going to do another demo. So like if you're not 100% yes, that is a-okay. Still a bit iffy. That's okay. Yeah. So what I really want you guys to have right now at this point is linked lists are a data structure that have a one-way relationship between nodes. And nodes are made up of data and pointers. The end of a linked list has a null pointer. Does that part all sound reasonable? Okay. Got a G2G, excellent. So this this one's a little bit longer, so if you can, I would recommend pulling this up on your computer too, so you can scroll through it. This one also, I think that YouTube channel that I posted has explanations of this longer piece of code. I think it's just called like linked list 1 or linked list 2, and it goes through and walks through this code, so you guys have that too. So this is interesting. So this class is a very, very long class. So let's take a look and see why. Because I mean, like this class was only like, what, 4 lines? Why is this one, if we're making a linked list, so much longer? What's one thing that just looking at them and just looking at the just looking at like just the class names, what do we think is different? It has functions in it this time. Yeah, we got functions. What else? So one's called linked list and the other one's called linked list node. So what do we think? What do we think the difference is? What do we think we're going to build with this class versus the other class? One is an actual list full of little node components, exactly. Yeah, so the first class that we made just makes little nodes. And then this bigger class is going to make this huge data structure of a linked list. So, and we can see that that's being used here because we're like, hey, make a new node using that other class. We still hand it in data. We have an add data function. Fabulous. Cool. So the first part that our constructor just does is just makes an empty thing that doesn't have anything in it. It's just like here, this is null. Wonderful. And it's using that kind of, that's a weird notation. It's just saying, let me finish this thought and then I will answer your question, Tyler. Wherever our head is should be null. And so we're using an array notation to access that class to set it the first thing to null, wherever the first thing ends up being. So Tyler asked, once data is submitted, does it just fall into place? And then he also said, can you edit or move once it's added? Those are very good questions. So the reason that it falls into place is because we set where the pointer is to set it into place. And editing and moving a linked list is a pain. You can do it, and we'll talk about how to do all of it. But because we have a much stricter relationship between the order that our data is in, it is much harder to move things. Because like think about in an array, you can just shift, unshift, pop, you can split and pull, and like the rest of the array will just kind of swoosh back to whatever it should be. So like if I have an array of 10 objects and I get rid of, you know, object at index 4, everything else will pull back into place. In a linked list, because each thing has a relationship, if I had a linked list of 10 items and I removed item 4, unless I tell the linked list that there is a relationship between 3 and 5, the list just breaks. And we'll see that in practice. Also, the videos kind of show how that works too. But yes, so you can move and edit them. Editing them is not near as hard as moving them, but moving them is really hard. And then Sarah asks, is this related to databases? You can use, not necessarily, this is a programming data structure. Databases do kind of have this relationship that, you know, if you delete stuff, it might mess up your indexes and stuff. But this isn't necessarily a database thing. It's a overarching programming data structure thing. And the entire class isn't just data structures. Cool. So those were good questions. Those were good questions. Do we have any other questions? Okay. So this add function creates a new node. Make sure that if the beginning, if we're just starting our list, we actually start our list where it should be in the head. And then we look at the current node. We go through our entire loop. I'm sorry, we go through our entire list with a loop to find the end where next equals null. And then we put it there. Yay! So that's all the add is doing. It makes a nice little check to make sure that the beginning actually exists. If the beginning doesn't exist, we make it. Otherwise, we look for the end when our pointer is equal to null, and then we add our data. How do we feel about this adding stuff to our linked list? Does this please feel okay? All right, we've got a G2G, excellent. Our next, good but will approach with caution, yes. Data structures are really hard. A lot of people really struggle with them, and like, these are really good interview questions. These are really good for you to understand like how JavaScript really talks to itself. If you were solely working in JavaScript, you might not use these, but if you're going to talk to any other languages, you'd probably use this data structure. So let's look at this next little function. The next one is get, and we're asking it for the index. So we got to make sure it's a positive value. We can't have a negative index. That makes sense. We look at our pointer and set it to the head because we want to start at the beginning. We keep track of where we are with just a, you know, little I. And then we just make sure that we're not at the end of the list and that we haven't overstepped our index, and we just hop through and look. And then we return the data if it's not null. What is that? What's line 73? And what do we got going on there? That's a weird little line of code. What's going on in that piece? Sorry guys, I was trying to move stuff. Maybe. So what is line 73? What is that? Ternary operator, yeah. An if-then statement, exactly. I think that's close, but you know I have no idea how to spell ternary. So what this is saying is, if not null, then current data, else undefined. Yeah, excellent job, Chuck. Yep, exactly. So if the current data isn't null, we just want the data back. But if it's null, we're going to say undefined. Beautiful. And then we also just have like, if our index is super wonky and a negative number, we return undefined also. So this is just some like error checking to make sure that we're in the proper place in our linked list. If I say array, when I'm talking about these, just be like, game over, no, none, because they're totally different structures and I don't want to confuse you guys. And then also notice that we're handing in index as a parameter. So that's what it'll give us. When we call this function, we give it a, where we want it to be. And then it'll just find it for us. Or it'll be like, nah, that doesn't exist. This one, so this remove one is kind of a doozy. Because when we're trying to add and remove stuff in linked lists, they get really messy. Because again, we have all these relationships. And so it's like if you had like a stack of books and you wanted to remove like the one almost at the bottom, if you just pull it out, the book stack's gonna fall. So you have to establish a relationship. And that means like gently pulling out the book and gently setting them down. So you kind of do the same thing when you're using this linked list structure in code. You pulled it out and then be like, okay, index of 3, now talk to index of 5, and then everything else will work. So our first thing, we just make sure that our list isn't empty because we can't remove anything. If you don't have anything, we can't remove anything. And then we also make sure that we don't have a weird index, because if, we try to do something like remove -1, it'll throw a fit and be very angry with us. So we just get rid of those. And look at that, it's throwing an error. See, it's throwing a new, and look at that, that's fancy. Look, we got this thing called range error. What do we think that means? Why is range error green? It is green because it is a special, I don't want to say instance because that's a little bit confusing. It's green because it's a specific error instance. So error is an object and it has all those different methods and properties. Range error is a method of the error object. So it's throwing a more specific error. So it's giving us more data than if we just threw a regular error. Fancy, this is very fancy. This is also something that a lot of, like, I love JavaScript, but this is something that it doesn't really implement really well, and other languages really shine in this division. So like C# and Java will give you really like valuable information with their error messages, and JavaScript is kind of like, I don't know, man, it doesn't work. What do you want from me? But we can give it a little bit more structure by using specific implementations of our array object. So this range error, which is pretty cool, tells us specifically that we have stepped outside of the range of our linked list. You can use range errors for anything that has a range, so lists, arrays. We'll talk about stacks and queues, hopefully today. Yeah. And all it's saying is our range is like our index for the whatever we're using. So, you know, if we have 10 objects in an array, 0 through 9 are valid range options. So if you put like -15, saying, hey, that's not in the range is what we want versus just like, it's broken. So yeah, good question. So this next little chunk, if we're removing the very first element in a linked list, we can do weird stuff and we don't want to break the entire thing, because let's think about it. What would happen if we removed the first item from a linked list and we didn't do anything to connect other pieces? Borked and broken, yeah. So if we remove the first position, we can't access the linked list anymore. So you have that whole list hanging out, doing its own thing, but because you don't have the first starting position, you can't see anything else. So we got to do some adjustments to it to make it behave properly. So our first case is that we just take it, we look at the data, and we hold it somewhere else in the temporary holder. We replace the head with the next node. So this is position 0, this is position 1. We go, okay, so we pulled the data out of position 0, we're holding it over here, we just set it down. Then we're going to take position 1, okay, you're now position 0. And then we just return, we're done. Cool, so that's our special case, because if we're removing stuff from the beginning, we need to reset our head for the whole list, otherwise things will get very angry. So next thing is we're gonna have a pointer. We started at our head because that's what we want to do. And notice that, we've done this assignment after we've done this check. And why do we care about that? What do you think would happen if we tried to assign it and then we like redefined everything and then tried to use it? What do we think would happen? The boom boom error, snap. It would have an aneurysm. So weirdly enough, I don't think it would cause an error, which is worse. So if we defined this current as the head before we made this check, it would work just fine as long as we're not at the beginning of the list, which is fine for most cases. But if we were at the beginning of the list and we assigned current before, we would be pointing to that empty space. So like most of the time, if we did that assignment at the top, it would work. It would just be like, yeah, man, that's fine. But then that special case, when we're at the beginning, we would have a null value and then it would break. So these weird cases you typically only find after you've worked through your code and then you get a weird exception. And so thinking about where you're assigning stuff can really impact your whole code. So that's why he's down here. Even though typically when we do functions and methods and stuff, we put all of our property declarations at the top. Like we assign all of our variables at the top, but that's why this one's not at the top, because we got to do some condition checking first. So then this is, so that way we can look at what's behind us. We just set it to empty. And then Sarah says, I can attest to that. My stuff has been worked up and all I had to do is move the code for it to work. Yep. And that's why that concept of like scoping is so important and like understanding where things are pulling from. But it can be confusing. It can be really confusing to be like, I don't understand why moving my, you know, variable assignment 6 lines down makes it behave. Yeah, making sure your script tag is in the correct place is a fundamental piece. Agreed. Yeah, yep. Moving just trim around just to make sure that it works. Yep, yep, yep. Yep, yep, yep. Yeah, and that's why using like breakpoints and like handwriting code out can really be a helpful tool, because then you'll be like, oh, because like when I was writing the solution for that problem, the default insert too, yes, if you were in VS Code and you're just kind of like letting it type things for you, you might get some weird stuff. Like the one that it always gives me is like if I try to do like just ARR for array, it tries to push this like huge thing and I'm like, I don't even know what that is. What are you talking about? So yes, make sure VS Code is not setting you up for failure. But yeah, I want to get through this remove function and then we'll do like a quick 10-minute break and then we'll come back for just a little bit. Yeah. Cool. So then we have just another counter just hanging out. This is the same loop as the one in Git. We're just making sure that we're still in our index and we haven't stepped over our boundary. We'll make sure that we found our thing. We return the value that was just removed. And then if it wasn't found, we say that the index isn't there. So yeah, so all we're doing is just taking it. This line 123 right here is the piece that reconnects both parts of the list to make them talk to each other again. So yeah. So that's the get and remove and add for our linked list class. This is some weird notation right here. Basically, it's just like saying like for everything that we have, we can do this kind of stuff. This yield is also really weird. I think this is the only time I've ever used yield as a keyword. I'm pretty sure all it does is it gives information back out, like return, but without stepping all the way out. So when we return a value, it pulls everything out and stops that code in place. And yield just gives the data, but it keeps going. You know, like a farming yield, I guess. You keep going. This symbol iterator thing, we created a symbol up. Where is he? Up here. It's just another little thing. It's just a like unique representation of something, and then we come down here and be like, it's the values part. So that way we can have both pieces. And then bam, it's much easier to see adding stuff here. And it uses that add from the class up here. And then we ask it to use the get method. We ask it to print out everything. And that's kind of a weird notation. For color of list is kind of like a for each loop. It's just a for of loop. And then we can remove stuff, get stuff. And then this is some magic, honestly, is these three ellipses, when they're put in this context, are called spread operators. And so it takes it and puts it into an array. So then we can use the array for things if we want to use an array instead of a linked list. So like we decide that the order doesn't matter anymore, or we know that we want to be able to add and remove things much easier. We want to push it to an array. We can do stuff like that. So now if we run it, we just get all the values that we added, which is cool. So Sarah asked, can you make it an array and then make it an ordered list again? Yes, there's not a magic little operator for that though. You'd have to go through and like add each thing in the array back to a list. There's not a magic way to do it. Well, this little like spread operator is pretty magic. So you just have to do a little bit of work. So like just like a for each loop and then for each add to whatever list you want. Cool. So those are linked lists. These are good for interview questions. You will get asked them. Like, one of the problems we'll spend time with is reversing a doubly linked list in place, which is like, but it's a common interview question, so I want to at least have you guys have exposure to it. Genuinely, if they ask you that question, most people can't do that. So you just want to work through it in the best way that you can. Cool. So do we have any questions about singly linked lists? All right, and then Sarah says, sounds like it could possibly be an easier way to edit data in the list. Yeah, it could be. I don't think that's what most people do, but you definitely could do that. Does anybody have questions about singly linked lists or like data structures in general and like why we care? Cool. All right, let's take a little bit shorter break than normal. Let's come back at 10:20, and then I'm going to let you guys go at 11, so that way you're not losing any lab time for Donna's thing at 2. All right, I'll talk to you guys in a couple minutes.